Alright, this is our virtual prototype. This is our Purdue Ferris wheel gumball machine. Show a video of this. See the motion. This is a high frame rate, so it's rendering slowly. But you can see we have gravity and friction included in this motion so that all of the chairs right themselves and their motion is damped by the friction. We have a hand crank powered mechanism that drives the front wheel, the fancy wheel that has the Purdue logo etched into it, and that transfers the motion through the seat axles to the back wheel and turns the whole structure.
Some of the more difficult parts to make were the slide, which was mainly done with helical sweeps and regular sweeps, as well as the Purdue logo. We had to import a picture and had to kind of trace out parts of it to be able to cut it out like a Purdue logo should look. The back wheel, the gumball will actually go in one side of it. It will drop into the wheel itself, and then when the wheel turns, the gumball travels through the wheel and pops out the other side. And it'll drop onto a chair where it'll turn around the whole wheel and then drop off down into the compartment in the bottom. And this is our physical model. A lot of things didn't fit at first. We had to do a lot of sanding because tolerances weren't as much as we thought they would be.
We're also using ball bearing instead of gumball since it's like perfectly round.
Drop it in the top, it rides around the slide through the wheel and falls into the slide, and then as you crank it around.
And sometimes that happens.
Yeah.
It worked like 7 out of 10 times.
Yeah.
Like,
well, it's because mainly no matter what ball you use, it's going to weigh more than the chair. And the chair is already back heavy, so it's going to tip, or front heavy, so it's going to tip backwards. So every time you drop something on the front, it's just going to tip it more. And sometimes it just tips it too far and it falls right away.
do you want to try it?
Yeah.
You want to try it?
Sure. Let's see if we can get a letter that we know works down here.
So with the chairs, there's also the little bucket. It's the white bucket. It's made as a second part, and originally we had the idea of having that the only piece tipping. But due to interference, we actually had to change that and make it as far as one solid part. So.
For the purposes of the demonstration, we'll start with the ball in the bucket.
So, once it falls in there, it would ride around the Ferris wheel. And then there's a little leg back here that catches on the bucket and tips it out at the bottom. And it drops off.
Any questions? You modeled the gears, right?
Yes.
Yes,
Yeah.
everything is
The gears that were part of the influence spur gear
Yeah.
template, and then we just modified them for our use.
The only purchased parts are like the wood, and for the base, the bearings that we used in place of the gumball, and the axles that the chairs sit on.
There are, I believe, 30 SLA parts to it that we had to fit into the build platform.
And is it,
So our total volume was about 14.5.
is it glued mostly?
Yeah, it's glued.
How'd you
Well, it's
make-
glued, and then our slide actually has interlocking puzzle pieces. So the slide pieces fit together on
Yeah.
on their own.
And how do the gears? What do the gears spin on? Just
That's SLA.
okay, so it's just
It's just like an SLA extension, and it's just sanded down so you can spin it around it, which is why it's harder to do it smoothly.
You could show them the puzzle piece on the slide.
Okay, we gotta keep moving. Sorry.
That's all.
So the main idea behind our project was to recreate a Tron light cycle. One of the biggest features is a hubless tire design, so that was one of the main ideas that we had. And you can see here, you can't see any spokes or anything. It's mostly just a hubless Tron light cycle. I mean, obviously put our own twist on it. But as for the mechanism, the main components are essentially just these two main gears here. We have this drive gear in here, you can see. And then around this outside tire, you can see that gear right there. We actually ordered a gear from a website, and we were planning on drilling out a hole, but obviously the rim thickness of the gear would be quite thin. So as a compromise, we just made a mold of it. I cast a resin mold of the gear so we could put it in between the two halves of the wheel that we designed. So that was a little maneuvering we had to do after the fact so we could actually get it to work. And as for the motion, you can see here there's a motor running the wheel and it's spinning there. And the rear wheel is free spinning so that while it's running, all the wheels spin.
We were talking about the O-rings and how you make the tires.
Oh yeah, the tires were done with a lot of revolves and a lot of extrudes and then patterning around the tires. And there are also slots put in it so that we could add O-rings or rubber bands to provide traction on the wheels. And we pretty much need to make them exactly because they need to fit perfectly around the hubs and everything. And we did have to do a bit of sanding. We thought we left enough clearance in the design, but clearly not, so we need to be a little more generous there.
So everything on the bike is made out of SLA except for the gears, the resin cast, and the motor, the 3 AAA batteries we have in there, and the LED light because this is a Tron light cycle. Otherwise, the entire body, the outside geometry was made 100% out of boundary blends. So there's no extrudes, no revolves, no variable section sweeps. It was all boundary blend geometry, and that's how lots of automotive designers design their cars, right? Because you have these complex shapes, and if you look at the bike, you can kind of see what I'm talking about. There's just the geometry is too complex to make it out of anything but a boundary blend. So that's why when we pull up our model, there's a whole bunch of lines everywhere, and those are part of the lines that we use to create the geometry. And then that was for the outside geometry, and then we cut it in half and mirrored the cycle, and then extruded out what we needed for the motor and the AAA housing assembly and the LED light. Another thing in the physical construction of this model, you have lots of friction between the components. So when we design the tires, we design them to only touch the inside hub on a certain rim. So not the entire outside hub is sliding on the inside hub. But there's a lot of grease on that hub assembly right now. So with that, show you.
It's not quite as fast as the real Tron light cycle, but
as you can see, it's all internal, so it looks a little, I don't know, mysterious possibly.
I'm gonna show everybody the light.
and there's the light in here, so when you turn it on, you can see the light in there. It shines.
We wanted to cut that hole in the side of it so you could see the gears and all the internal parts moving. Otherwise, it's kind of mysterious. You don't really know how it works. So we wanted one of the kids to actually be able to see how it works.
And in the real life cycle, they have the hole so you can see the transmission and whatnot. So, yeah, that's our hubless Tron light cycle rendition.
Any questions?